Hello everyone and welcome to Exambi. In this video, I'm going to talk about the IO subsystem, which is important for operating system and computer architecture chapters. Basically, this IO subsystem is a kind of topic which you will read in many different subjects with different perspective, but you should know the basic of the IO subsystem and how it is related to other subsystems in order to perform any task. So beginning with the IO management, first I will answer you why and what we need in the IO management. So IO management is basically the input output management, and it is one of the most important component of the operating system design. Whenever we are designing operating system, whenever we are making computer architecture, we have to keep this subsystem in very mind. Why we have to keep this thing in very considerate manner? Because of these reasons, because different methods are there to control the output and input devices. There are always new types of devices which keep coming in the market, and also there are so many different types of IO devices which are already present in the market. So you can see there is a wide variety of input and output devices, due to which there might be different techniques and there will be different kinds of algorithm that will be needed in order to make the smooth management of the input and output devices. We basically use different kinds of other devices in order to make IO management easy, like ports, device controller, buses, and these things together help us with the IO management. When we are connecting them, the device driver enables the encapsulation of the device DD. So in order to use any device, we need a corresponding device driver. Device driver is kind of a software program which will help you to communicate, uh, like to establish a communication between the IO device and the particular system. We'll learn more in detail about the device drivers when it comes to the communication in the IO subsystems. But for now, you can just keep your understanding till the point that this particular thing is related to something which acts as an interface between the computer and the IO device. Now, before understanding anything about the IO, we should understand the bus structure for the peripheral computing basically. So in the peripheral components, this is the basic bus structure that you will come across. This is basically a PCI bus structure. So you will have a PCI bus. Bus is basically the component which will connect the CPU and the expansion board, the modem, the network card, or the hardware things. So for the communication thing, we will be using a PCI bus for all the major subsystems. Now, you can see there are controllers, different types of controllers: graphic controllers, bridge controller, SCSI controller, IDE desk controller, expansion bus interfaces. There are different kinds of interfaces and the controllers which are present in this diagram. What are these things? So controller are basically used to operate the port, the bus, and the devices which we need as an electronics. Okay. Then you can see the very next thing which seems very unusual is the port, parallel port and the serial port. Port is basically the point where the connection of the devices happen. So this is basically the connection point for all the devices. Rather than this, all the things are pretty much known to you, like processor, monitor, the cache and the memory, the keyboard and everything like this. Other than that, you do not need to go in that detail to understand the PCI bus architecture. Okay, so this is the PC architecture. Now, before going in detail of the IO subsystems, you should know the different types of IO devices. So IO devices varies from the storage, transmission, human interface, and the specialized category. I will give you one example of each so that you will be able to understand what kind of categories they belong to. Storage category: RAM, hard disk. There we store the data. They are basically the storage devices. They are also the input and output devices. Transmission categories, which are used for the transmission. Transmission like modem, the network card, these kinds of things. Then human interface categories like monitor, keyboard. Basically, the humans are going to interact with these things. Specialized categories like joysticks. So Basically, all the devices which are IO devices can be categorized under 4 pillars, and these are those 4 pillars. Now, component of the IO subsystem. So, in order to understand this difficult topic, what you have to do, you have to first understand what is an IO subsystem. So, IO subsystem have the system calls. System calls actually help to establish a kind of communication, to have a kind of code when the IOs are communicating with the system. So for that we have IO system calls. So IO system calls encapsulate device behavior in a generic class. So there you can see there is a kind of encapsulation which is happening. Now there comes the device driver, which actually hides these kinds of differences among the different IO controllers and the kernel, which is the basic system or the soul of the operating system. IO subsystem is independent of the hardware. You never know that which particular hardware you are using for the IO subsystem. So it is independent of the hardware. We simplify that the job of the operating system developer, device manufacturer, they have to develop a device drivers to suit for the specific operating system. So that's where the device driver comes into the scenario, because we have the operating system which is independent, we have IO subsystem which is independent. How these two will communicate? These two will communicate using a specific software that is called as device driver. Now you can see two diagrams here. The first diagram actually states the kernel subsystem. You can see you have kernel IO subsystem, then you have the kernel, and on top of that you can see there are different device drivers. For example, for mouse we have mouse device driver, and then there is a device controller, and then you are able to interact with the mouse. So whenever you are going to interact using mouse to the kernel, there will come two entities: mouse device controller and mouse device driver. So there are the layers which are hardware layers and the software layer. So the hardware layer will have the mouse and the mouse device controller, and the software will have the device driver and the kernel IO system and the kernel itself. So you can now see how these things are being separated. The other thing talks about the different aspects of the IO devices. For example, what is the data transfer mode, the access method, the transfer schedule means the sharing, means the device is shared or it is dedicated device. Device speed, IO direction, it is one direction, it is read only, write only, what kind of direction, like the magnetic hits, what kind of direction it is having. For example, they are having some examples in the third column, you can just relate to that. So for your understanding, this is the extra table which you can utilize to understand the IO device features or the characteristics which they will have. After that, talking about the subsystems, we understood the kernel subsystem. Now, what actually the kernel subsystem do? What are the functioning of the kernel's IO subsystem? So the kernel IO subsystem has these different kinds of things. Scheduling. Scheduling, like what IO requests are coming, what is the device queue having. These all things are being taken care. Buffering. Buffering happens when the source or the sink are not in sync, basically. When there is a device mismatch or the speed mismatch between the devices, then we actually encounter the concept of the buffering. So these are the things that we do under the buffering, like to cope up with the device speed mismatching, to cope up with the device transfer size mismatch, and to maintain the copy semantics. Okay. Then there is the concept of caching, which is like holding the copy of the data. You always hold only one copy of the data, and it is the key to the performance, because as fast your caching processor will be, more fast your CPU will act. Then spooling. This is basically something which is a buffer that holds the output for a device before putting it into. Okay. Then there is a device reservation. Here you actually provide exclusive access to a particular device for the system calls, for the allocation, for the deallocation, and you actually watch out for the deadlocks, because here the resource allocation is also happening. So these are some of the duties of the kernel IO subsystem. Now, what are the component of IO subsystem? There was the kernel, now we have to understand the IO. So similarly, IO subsystem also perform all these things which a kernel performs, but in a different domain. Here you have a channel's job to keep up with the IO request from the CPU and pass them to the control unit. These IO channels are basically programmed unit placed between the CPU and the control unit, and their job is to synchronize the fast speed of the CPU and the slow speed of the IO. You always know that the CPU is much faster as compared to the IO that we are having. Then it is also their duty to make it possible to have an overlapping IO operation with the processor so that CPU and IO can run concurrently. So sometimes CPU will run, sometimes IO will run, and none of them are idle for a long time. Now, channels are used for IO channels, and each channel program specifies the actions to be performed by the devices. It also controls the transmission of the data between the main memory and the control unit. So there are the channels which actually uses the IO channel programs. Then we have IO control unit, which actually interprets the signal sent from the channel, and it is sometimes the part of the devices, and sometimes it can be attached to several similar kind of devices. One device per unit, or like one control system can be shared among, or like attached to different similar devices. So this is the component of the IO subsystem. Now, at the end, for the understanding of the IO subsystem, we should understand the IO commands, how it basically starts, what is the end and what is the end. So at the start, it is the IO commands, like what kind of command, read, write, rewind, whatever kind of IO command is given to the IO subsystem. Then it will identify the channel number to which channel we are going to take care of. Then the address of the physical record that has to be transferred from the secondary memory basically, and we have understood this particular concept in the virtual memory as well. So now you can establish a link between the IO subsystem and the virtual memory as well. Starting address of the memory buffer from which or to which the record has to be transferred. So that is the way how the IO commands actually work. Because the channels are as fast as the CPU, they can direct several control units by interleaving the commands. So there may be some CPU command, then IO command, then CPU, and then IO command. So there will be interleaving of the commands as well, because these channels are as fast as the CPU speed also. The IO devices are slow, but not the channels. Each control unit can direct several devices in the similar manner, and channels are often shared because they are most valuable item in the part of the IO subsystem. So by this, you will get an idea of the IO subsystem. This was all for this video. In the next video, I'm going to discuss how the communication happens, how the device driver is responsible, what is polling, what is interrupt. All these are going to be discussed in the next video. So if you like this video, do hit the like button, hit the subscribe button, and hit the bell icon so that you never miss an update from our side. And also, if you face any difficulty in understanding the video, please drop a comment and we will be happy to help you out with all your doubts. For more understanding, you can go to our website, that is www.exambi.com, and check out the relevant courses which you are targeting for your government exam. So this was all from my side. See you in the next video. Till then, keep practicing and stay updated.